Hello everyone, I'm Arsha Sultana, she's Snehalata and he's Nagaraju and we are from CSE. We are here to give a brief information of data structures. We all have heard about data. All the files we store in our system is data. Have you ever thought how is your data so organized in your system? So here comes the concept of data structures. Data structure is a specialized format of processing, organizing, retrieving and storing data. There are several basic and advanced types of data structures which allow the user to arrange data to suit a specific purpose within less space and time complexities. Data structures are the main part of many computer science algorithms as they allow the user to manage the data in an effective way. It plays a crucial role in improving the program or software, as software's main objective is to retrieve the user's data in an effective way in less time. Data structures are divided into two categories, nonlinear data structures and linear data structures. Here we have the difference between linear data structures and non-linear data structures. In linear data structures, the elements are arranged in a linear way, thus they are easy to implement. Whereas in non-linear data structures, the elements are arranged in a non-linear way, thus the implementation is complex. In linear data structures, the time complexity is more, whereas in non-linear data structures, the time complexity is less. Linear data structures are mainly used for developing the software and in many other computer science applications, whereas non-linear data structures are used for image processing and artificial intelligence applications. Examples of linear data structures: arrays, linked lists, stack and queue. Examples of non-linear data structures: trees, graphs, tables and sets.
Array is a linear data structure in which values are stored in continuous memory locations and we are accessing the elements using index, that is the position of the elements. This is how we store the elements in the array, and these are positioned 0, 1, 2, 3, 4, which is called as index, and these are the addresses of the each element, and this is called as the base address, which is the address of the first element. There are two types of arrays, one-dimensional or multi-dimensional. Arrays are implemented using stacks and queues. Linked list is another linear data structure in which elements will be not stored in continuous memory locations, but these elements will be stored using pointers. We store the elements in the form of nodes in linked list. Each node consists of data field and address field, and first node is called as head node and the last node, the pointer, is stored as null. Before using the array, we have to initialize the size of the array, thus there will be shortage or wastage of memory. Insertion and deletion becomes more time consuming due to lot of shiftings. To overcome this, we have linked list. In linked list, we don't have to declare the size of the linked list in advance. Whenever we want to increase or decrease the memory, we can do it during the runtime. Here comes the application of linked list. Linked list is used in image viewer, GPS navigation systems, speech recognition and video games, and generally stacks and queues are implemented using linked list.
Stack is a linear data structure where the elements are stored on the principle of last in first out, where the last inserted element is deleted first. This is the mathematical representation of stack. It indicates its stack is empty. We have to insert first element. Inserting an element in the stack is called as push. We have inserted first element as 1. Next we have inserted element 2. Then the deleting an element from the stack is called pop, where the last inserted element 2 is deleted first. That's why it is called last in first out. The operations on stack are done using an index called top, where top is initialized to -1. When top is equal to -1, it indicates stack is underflow. When top equal to size, it indicates stack is overflow, where we cannot insert any more elements. There are several operations we can done on stack is push, pop, display, etc. These all are done using only one end. Applications of stack. There are so many applications of stack. Expression evaluation and expression conversion can be done using stack. Backtracking, function calls, recursive calls all also can be done using stack. Stack can be implemented using linked list and arrays. Next data structure is queue. Queue is a linear data structure where the elements are stored on the principle of first in first out, in which the first inserted element can be deleted first. This is the mathematical representation of queue, where rear points to the first inserted element and front points to the last inserted element. Inserting an element in queue is called as NQ and deleting an element in queue is called DQ. Initially both front and rear are initialized to -1. Applications of queue. Queue can be used in handling hardware or real-time system interrupts. Queue can be also used in routers and switching in networking. Handling website traffic and maintaining the playlist in media place also works on the principle of queue.
The next data structure is trees. A tree is a non-linear data structure that contains nodes that are connected in a hierarchical manner. The nodes are present at different levels connected with edges. The first inserted node is called the root node, middle nodes are intermediate nodes and the last nodes are called leaf nodes. There are 4 main types of trees: binary tree, binary search tree, red-black tree and ABL tree. A binary search tree is a special type of tree in which each parent node can have maximum of 2 nodes. Properties of binary search tree. All the elements less than the root element are inserted towards the left side of the tree, and the greater than the root element are inserted towards the right side of the tree. Trees are used in compilers, indexing, priority queue, Huffman coding trees, etc. The next data structure is graphs. A graph can be either directed or undirected. A tree is a special kind of graph with some restrictions. In a tree, there is only one path from root node to any node. In a tree, there is an edge representing the parent-child relationship. Tree cannot have loops or cycles. This graph is a data structure without these restrictions. So here is an example of a directed graph. Here A, B, C, D, E are nodes, and these are the edges. Graphs are used in social media applications, operating systems, and many other computer science domains. Every algorithm has average, best, and worst time complexities. Here, time complexities for different operations like accessing an element, searching an element, insertion, and deletion. In arrays, accessing takes order of 1 time, search, insertion, and deletion takes order of n time. For a singly linked list, accessing and search takes order of n time, but insertion and deletion takes order of 1 time. Thus, singly linked list is better than arrays. Here we have the time complexities of some nonlinear data structures, and most of them are order of log n. Data structures is not limited to just these, but we have many other data structures. Based on the type of the data, we should choose the appropriate data structure. Thank you.